one of the things that's really important in math is knowing how to use a formula. And there's a ton of different formulas. You're going to have formulas in your science classes. You're going to have formulas in your other math classes. And so what I did is I picked a formula that I think is somewhat useful. Changing from degrees to Fahrenheit. I don't know if you've ever traveled to the United States, but they say their temperature different than we say our temperature.
Fahrenheit.
They say Fahrenheit in the United States, we say Celsius. And that's quite a bit different, right? And it was also very important that you know which one you're talking about. Because if someone said it's 80 degrees outside, and they didn't say if it was Fahrenheit or Celsius, I'd be nervous to go outside. 80 degrees Fahrenheit is like,
What would that
not
look
bad.
like? That's
That's
what,
not bad.
20?
It's probably more like 20. We'll write it down. We want to figure it out later. We'll figure out what 80 degrees Fahrenheit is later. If it was 80 degrees Celsius outside, oh my goodness.
What would that do?
What would that do to you? Right? Like people get heat stroke when it's like between over 40 degrees. So I'm thinking if you were in 80 degrees for too long. Hey, do you know what happens at 100 degrees? If you've done this in science, what happens at 100 degrees Celsius? There's something important about 0 degrees Celsius and 100 degrees Celsius. Water boils at 100. So if you went, I'm just thinking what's inside of me. It's like
Just stay inside.
blood and guts and stuff. At 100 degrees,
Water.
you would start to boil. I don't think that would be, I think you would die. So, it's important to say what unit you're working with. And there's a way to change Celsius to Fahrenheit and Fahrenheit to Celsius, and they have formulas. So here's two formulas. They involve rational numbers. One of them has a rational number as a decimal, 1.8. The other one has a rational number as a fraction, 5/9. So it fits into what we're doing right now because we're moving more towards using our calculator and using fractions and decimals. So right now someone says, oh, it's 30 degrees Fahrenheit outside. What's the actual temperature? So in this situation, you know 30 degrees Fahrenheit, so we know the Fahrenheit, and we don't know the Celsius. And there's two formulas. Okay, and actually I'm going to give you a third formula as well from these in a bit. Both of these formulas are actually the same.
Yeah.
They're the same formula, just written in two different ways. I'm going to give you another formula as well. Right here, I'll draw it in black. Where you get the Fahrenheit by itself. Okay, and it is equal to Celsius or
The reciprocal.
okay.
It has been reciprocated.
So, all four of these formulas, they all mean the same thing. But they all do slightly different things. One of them uses decimals, one of them uses fractions. And some of them really help you find Celsius, and some of them really help you find Fahrenheit. So the ones that are Celsius equals, those would be formulas you would use if you wanted to find the Celsius. The Fahrenheit equals, or the F equals ones, those would be the ones where you know the Celsius and want to find the Fahrenheit. So what we're going to do is we're going to practice how do we use formulas, and how do those formulas, how do we type them into our calculator. Okay. So, number one, how do we use formulas? If we know the Fahrenheit, that means we can replace the F in one of these equations with 30. So what we do is we go C equals, and I'll look at it with the decimal, and I'll look at it with the fraction. If I use the decimal one, I'd plug in 30.
That matters.
I'd plug in the 30 for the F, and now we have to do our order of our operations. Okay? Some people have calculators that let you type this in exactly as you see it, and then you don't have to worry about order of operations. I'm going to show you a calculator that does that. So notice this calculator lets me write a fraction.
These two.
Try it on. I'm not sure if the calculators that you have would let you do this. I can push enter and find out that it's negative 1.1 degrees. Okay? If you don't have a calculator that types it in exactly, okay, we need to do some of the math first. And we can do this 30 minus 32 on our own first. 30 minus 32. Again, you have your calculator, so do it in your head. Imagine a number line. You're at 30, going 32 to the left. And then let's check it on our calculators. What do you think you get when I do 30 minus 32? Wow, 30 minus 32. Should I get 2? I should get negative 2. Sure enough, negative 2. So we can go back to our formula here, and I get minus 2 over 1.8. And when you have a fraction like this, do you know that on your calculator, that's your divide button? So I take out my calculator, I go negative 2 divided by 1.8, and I should get the same answer that I got before, negative 1.1 degrees. If you were given the same thing, but you had the other formula, 5 divided by 9, you plug in 30 for the F. So now I am using this formula right here. What's nice about this formula is the one on the left, you might not have been able to type this whole thing in by yourself. But all calculators can type this one in. So let's go to our calculators and type this in exactly as you see it.
Is that because on the left side you'd have to put 30 minus 32 in brackets?
You might have to put the 30 minus 32 in brackets. And it doesn't show up. Whereas this one, so if I go 5 divided by 9, bracket 30 minus 32. I want you to type that into your calculator. We should still get the negative 1.1 because it's the same formula, the same way. I want to see if you get the negative 1.1 on your calculator. So try typing it in your calculator. Excellent.
Did you get it?
When you push enter on your calculator, you should get that negative 1.1. Brody, do you have your own calculator? Brody, do you have your own calculator?
Is it degrees that you always want to be in?
It doesn't matter for this question.
Okay, well, 5 divided by 9. You may have hit that. Did you get it? You did 9 over 5 once.
If you got the answer of negative 1.1, you can show one of us. Okay, we're going to do the 80 degrees next, but 0 degrees Celsius is 32 degrees Fahrenheit. And you might even be able to see, do you see that if you put a 32 in for the F, 32 minus 32, I bet you can do that mental math. you get 0. And even though there's a fraction there, 0 times 5/9, you get 0. That's one you can do for mental math. So this is an important one as sort of a benchmark. So when we see the 30 degrees Fahrenheit, that's less than the 32. It kind of makes sense that we got a negative 1.1 repeated degrees Celsius. So let's check out the 80. If it was 80 degrees Fahrenheit outside, would you wear shorts?
Yep.
Would you wear a jacket? Well, let's check it out. So I'm going to use this one with the fraction. 5/9, we plug in 80 minus 32. We can go to our calculator and type that in all at once. And on your calculator, use what? You're using the fraction button? Yes?
Yeah.
Okay, good. So
26 degrees.
let's figure out if we got this right. It should be. Go to my calculator. Some calculators let you type that 5/9 as a fraction. Some make you use the divide button. 80 minus 32. If it gives your answer as a fraction, lots of calculators let you switch that to a decimal. Oops, I hit the wrong button. 26.6 repeated. So I think I'd wear shorts.
Definitely.
How long do you think you have to wait for that here in Winnipeg? How many days are we going to have to wait before we get to temperatures like this again? How many months?
6 or 7.
6 or 7 months? Yeah, okay.
June.
Probably June. Sometimes June doesn't. Sometimes June. Sometimes May. Sometimes you get hot already in May. But I don't think we're going to get another one like that in a while. Now, if you were in the States, right? And someone from the States came here, and they're like, they ask you, how warm is it going to get today? And you say 10 degrees, and they say, what does that mean? Right? So you know, I'll do one more question. You know 10 degrees Celsius. Our question is, what is that in Fahrenheit?
60.
So we're going to use the Fahrenheit formulas. And they both work really well, because you can either use the decimal or the fraction. In fact, I probably like the decimal one here even better. So we go to our Fahrenheit formula. 1.8. We got 10 degrees plus 32. We can type that exactly into our calculator as we see it.
50.
And you get, thank you for typing it in. It would be 50 degrees Fahrenheit. So you're like, it's a high of 10 today. They say, I don't know what that means. Well, then you could use the formula and plug things in and tell them, well, that's the same as 50 degrees Fahrenheit. And they're like, oh, okay, so not really warm, kind of cool, I'll need a jacket. Right? Because we have it in our heads what we're used to, right? You guys are used to Celsius. Everything that's in Fahrenheit, when you go to the States, you'd be like, I have to switch it. Everybody who's in the United States, they're used to Fahrenheit. They have to come here, they have to switch it. There are some things in Canada where we still use Fahrenheit quite a bit. Does anybody know where we use Fahrenheit in Canada quite a bit?
Temperature.
Temperature for what?
Like stove.
Stove temperature, excellent, right? Like you'll read a recipe and it'll say preheat to 350.
Is all our kitchen
Okay.
utensils.
We had a friend from Europe visiting us. She wanted to cook us something, but her head is all in Celsius. So instead of preheating the oven to 350, right? Her recipe said preheat to whatever 100 and, well, let's figure out 300. 350 Fahrenheit, Celsius would equal 5 over 9, 350 minus 32. I'm going to type that into my calculator.
Uh, 176.
176, thank you.
Or if you round it up to the nearest number, 177.
177. Okay. So her recipe said 175 degrees Celsius. And she typed 175 into our oven. And the food was cold and not cooked for a very, very, very long time. And things did not turn out well. Because your brain is used to certain things. So units are very important. If you go to Europe and you set something at 350 degrees Celsius, your food is going to get super hot and burn right away.
Yeah.
Because that would be extremely hot. I don't even think the ovens go that hot.
They definitely do not that hot.
I think 500 is the hottest that an element goes to.
Not Celsius.
500 Fahrenheit.
Yeah.
That's what you use when you're trying to clean it. Okay, so using formulas. I'm going to give you some questions where I give you the formula. You have to plug it in, type it into your calculator, and use it. Today, we are doing some practice with calculator stuff. Oh, I've got a sheet for you later. We'll do a little bit of reviewing integers, but then what we're going to get to today is decimal place stuff. So first of all, I want you to do all 4 of those in your head first, and then type them into your calculator to check.
First in the, oh yeah.
First in your head, then in the calculator. Same thing with the multiplying and dividing. First in your head, then the calculator.
Are you gonna?
Okay. Sometimes they tell you temperatures, and they have decimal places. So we got to learn how to work with decimal places as well. In Winnipeg, average temperature in January minus 16. In July we got 19.5. How much colder is it? So we have to find the difference between these two numbers. Difference between two numbers is subtracting. So my first number is 19.5. And I need to subtract my second number, which is minus 16. Again, you have your calculator.
35.5.
You've got your head, great. But you want to do your calculator as well. So when we're typing this into our calculator, we type it in exactly as we see it. So 19.5 minus bracket negative 16. So your calculator is smart. It will work with the negatives. Subtracting the negative is the same as adding. You get 35.5. Now we're not going to do a lot of these because I've got a worksheet where we're going to do some stuff with math with decimals. So I've got a bunch of them here, but what I want you to do, and on the worksheet as well, what I want you to do is I want you to come up with an answer you think it's going to be close to. Okay? So I might do, instead of 3.8, I might do 4. Instead of 4.4, I might do 4.5, I might do 4 again. And I'm going to make an estimate. If I rounded down 4 plus 4, I'm going to estimate and get 8. Then I'm going to go to my calculator and I'm going to see how close that was. What is 3.8 plus 4.4? 8.2. And some of you might have been able to do that in your head. I've got ones for you to try that I know that you can't get perfectly in your head. So it's 8.2. You know what I would actually do if I wanted to do this exactly in my head? I'd be like, how far away is 3.8 from 4? It's 0.2 away. So I'm going to steal 0.2 from this one and think of it this way. 4 plus 4.2. See how I stole 0.2 from the 4.4 and I gave it to the 3.8 to make that one 4 and 4.2, and then I feel like I can do the 8.2 in my head a lot easier. Negatives. So if I rounded this one's close to -4. If this is 4, I'm going to say this is close to 0.
What?
Yeah. What is it actually? Am I close or am I way off? Go to my calculator. With the negatives, it's a little bit harder. -3.8 plus 4.4. It's actually 0.6. Oh, I gave it away. I did in my head, didn't I? 0.6. I have a paper for you. I want you, for each of them, to put your guess down first before you type it in the calculator. I specifically chose ones that I know for sure that you won't be able to do easily in your head, but you can estimate them and then see what you actually get.